Okay, so we're here now. Fair warning to Robert Mahmoud. I'm Braden. I am here another week in a row for MS Cubed. We're gonna have our third math talk of the year. I'm excited. We have our speaker of the hour here, Mahmud Azam, a double honors undergraduate in his final year, math and comp sci. But he will tell you that his first subject is comp sci. He's currently working on his honors thesis right now in mathematics, and his general interests just lie under the applications of category theory into a lot of different things like quantum theory and or quantum information and logic, stuff like that. And we're also joined by Robert again, just to field some questions, get some direct feedback. But if Mood is asking questions, feel free to type it in the chat or ask questions in the chat or come in our Discord, which is in the link below, and we'll get in if you get into the question queue chat. But I'll hand it over to Mahmoud. So if you want to start sharing your screen, I'll get that set up.
So can you see my screen?
Yep.
Cool. Right. So this talk will be motivating categories from like very basic constructions, essentially. But first, you got to give me some credit for that cursive because I'm not Robert, but I still pulled off that cursive, right? So, okay. So it's just going to be a series of constructions using set theory, and then we're going to see some general patterns and sort of try to capture those patterns in a definition. Okay, so let's start. So I'm going to start with a question. So can anybody give me the definition of a bijection? Like if anybody can feel free to chime in.
Is this time for me to go? Do I shine now?
Sure.
Oh yeah, I get to flex my muscles. Bijection is a map that's injective and surjective.
Now you got to tell me what injective and surjective are, right?
I'm gonna pull a sneaky on you. That an injective map is a map where the kernel only contains the zero element or the identity element, and a surjective map just means that for every point in the image, or I should say for every point in the codomain, there exists a point in the domain that the map sends that point to the corresponding point in the codomain. In other words, the image is equal to the codomain.
Okay, but I mean, so you use the concept of a kernel when you're talking about injection. That's assuming that you're dealing with some sort of a group or a ring or a vector space, that kind of thing, right? But I mean, the thing is, have you ever seen any other formulation of bijection? Like that's sort of like really easy.
Oh, you mean like just use say injectivity as in like it's a one-to-one map?
Okay. Well, your thing is correct, right? So it's completely correct. There's nothing wrong with it. It's absolutely the way we usually learn it and everything. But I mean, there's this another way to sort of see this. Okay. So if you have a map from a set A to a set B, right? I mean, can you tell me about any maps from B to A that sort of make F a bijection?
Oh, you're saying as in just the inverse map has to exist for a map to be a bijection. There has to be another map from B to A such that F composed with that map is the identity.
Exactly. So I always get this wrong, so correct me if I'm wrong. So G compose F is equal to the identity map of A, I think.
Yes.
And F compose G, like you gotta say you gotta have it the other way around as well. F compose G is the identity map of B, right? And like the identity map, just for the record, is like ID of A is just equal to A. Same for B, right? Okay, now you see, you can try to prove that if it satisfies this and this, F and G are both bijections, but like that's an exercise, of course. So the thing is here, I don't even have to talk about it being injective and surjective, right? right? I'm just giving you a second map.
Okay. Are we hearing a robot voice here? I think you're getting a little bit of feedback on yourself, Mahmoud.
Really?
Mahmoud's becoming a robot. They're taking over.
You can hear that too, Robert, right?
Yeah, I can. That's what happens when you take too much comp sci courses, kids. You turn into a robot.
Like, you still hear a robot voice or what?
No, it's good now.
Okay. That must have been like, I don't know, like network problems probably. That happens sometimes. So can you see my screen again?
Yeah, we can still see it.
Okay, cool. So what I was saying was, like, you don't have to talk about injectivity and surjectivity when you're talking about bijections. You just need this other map that goes back and makes that works as the inverse in both directions, right? So that's an interesting pattern that we're seeing. Okay, so let's see if we can take this, like, how far can we take this? Okay, so let's talk about like direct products or Cartesian products of sets. Okay, so what's a Cartesian product?
Well, Cartesian product. Oh man, you're really testing my algebra skills here. Oh boy. Cartesian product is when you take two and the Cartesian product is A cross B, where it's a set of all tuples. The first element is an element of A, the second element is an element of B.
That's exactly right. Now, can we sort of like define this in terms of functions, like in and out of A or B or A cross B and whatnot? Like, are there any special functions that we have from A cross B to A or to B?
We have the projection map.
So we have A cross B, and then like how many projections do we have?
2.
Okay, so we have projection into A, right? And the projection into B. Like, what do the projection maps do?
They just send they take the tuple of the cross product. So the projection map on A will just take that tuple and send it to A. So it'll just send it to the corresponding part in that set.
Absolutely. And oops, B. Okay. Right. So that's what it does. Okay. So it has a projection into A and a projection into B. But what's so special about this? So if I have a function going into A cross B from some set C, let's say, like, do I have any functions into A and into B?
Oh, hang on, what's going on? So we have a function from C to A cross B now?
Okay, I'm getting a lot of lag comments, so I'm gonna just try to figure this out here. Sorry about this.
It's all good.
I gotta figure out. I have like everything closed on my end. So sorry about this, everyone. If you can even hear me at this point. Oh my gosh. Making sure nothing's running in the background.
Yeah, I just got an email from Steve saying that
Yeah.
it's really lagging.
Yeah, I don't know what's going on.
Do you think it's the because there's a lot of people on camera? Do you think that might be why?
I don't think so.
I could switch off my camera, of course. I think I'm gonna do that.
Yes.
Yeah, I'm getting sorry about this. This is a very unfortunate. Sorry, Mahmoud.
It's all good. It's all good.
Not sure how to troubleshoot this right away. Yeah, it's on my end, Viom, if you can still see it. Um, all right, I'm gonna try to crop the cameras, see if there's any less. Uh, I don't think that's gonna make any difference though. No, it's not. Okay, this is kind of embarrassing. We're still live, by the way. I want to make sure. Oh gosh, turn my video off.